This is a review of Algebra 1. I want to make sure that you can draw straight lines, see where they cross. That's the solution to a system of linear equations. This is a system because there's two lines here. And we would really like our lines to look like this. Y, let's see if I can make this move. Y is equal to mx plus b. That's what we'd like to see, and we don't see that. We see that this 2x is over here, so we're going to move it by subtracting it from both sides. And I'll write the results below here. I will say y is equal to, the negative 2 is now on the right, negative 2x, and the positive 4. Okay, so now that looks like y equals mx plus b. And I'm hoping that you remember that m is the slope, that m right there, and that equals the change in y, how much it goes up and down, over the change in x, how much it goes side to side. Alright, and you look over here, and you say, well, there's nothing on the bottom, so it must be 2 over 1, right? Okay, so that for every step to the right, we're going to go from left to right, we always do with our graphs. We're going to say, for every step to the right we take, every one step, that's the number on the bottom, the change in x it would be 1, and the change in y would be negative 2 for this first one here. Because that's our slope in front of the x, that's the m. And the b, that's our starting point. If you look at this b here, down here it's plus 4, so we're going to go to plus 4 and plot our point right there. That's our first point. That's where we always start, with the y-intercept. Notice that this is the y-axis and this is the x-axis. And then from that point we're going to take one step over, like we said, one step to the right, and 2 steps down, and plot another point. And then we'll do the same thing again. 1 step over and 2 steps down, and 1 step over and 2 steps down. And we'll have our line based on that. If we go backwards, if we go to the left, we'd have to go 2 steps up, backwards 1, 2 steps up, and we have a straight line if we connect these dots like that, okay? I did the best I could with my straight line there. Okay, for the other one, it is not in that format either, so let's begin by subtracting x from both sides. And we have 2y now left on. After those cancel out, we have 2y is equal to, I'm writing the x first because I have mx plus b over there that I want to try to be like that. So I'm going to write the x first, the negative x, and then I'll write the negative 1. And I'm not there yet because I need to divide by 2. So let me do that. I'm going to say divided by 2, because again, my goal is to get the y by itself. I have to divide everything by 2. So I'm going to end up with y, because the 2's cancel, is equal to, now you may not have noticed it before, but there's a 1 in front of that x. And I'm going to put the number part out in front of the x. I'm going to say minus 1/2, because that we understood that to be 1x, so it's 1 over 2. And then I'm going to write the x. I'm just separating out the fraction before I write the x. I could put x over 2, but it just looks more clear to write the negative 1/2 in front, because that's where the m goes, that's the slope. And then I have negative 1/2, because I divided that 1 by 2 as well. Everything got divided by 2. So this time I'm underneath the x-axis. If this is 0 and this is 1, then negative 1/2 would be in between, so I'm starting right there at negative 1/2. And this time I'm being told I'm going to take 2 steps over, and then I'm going to drop 1. These are both negative slopes that I have here. Wait, I pointed at the wrong half. I pointed at the wrong half. Those aren't the half. It's the same thing, but I just pointed at the wrong one. I meant to point 2 over that 2. This is the slope over here in front of the x. The 2 over and then 1 down, okay? If you remember, last time I was using this over here, and I said that the change in y is on top. So the change in y this time is negative 1, and the change in x this time is 2. So I take 2 steps over, I'm at negative 1/2, and I take 2 steps over, and then I drop 1. So I went from negative 1/2 to negative 1.5, because I had to add 1 and I had to drop 1. So I'm going over 2 again, because the number on the bottom is 2. So I go over 2 and I drop another 1. And I go over 2 and I drop another 1. As many as I like, I can do this. And then I connect the dots again, best that I can in a straight line. Okay. And my goal is, where do they cross? I need to see where they cross. So here we go. We say that they cross about right there. And we would say, okay, what's the x value for that point? Well, it looks like it's about 3. Maybe not perfectly, but it looks about like 3. And the y value is negative 2. So the solution, according to the graph, is that my x is 3 and my y is negative 2. So that's the solution according to the graph. Now, there's another way to handle this, and I'll show you by rewriting both of these equations I started with. I have 2x and I have plus y equals 4. I don't have to graph this. And I'm going to ask you to look at this up here, and I'm going to multiply this second line by 2. And the reason I'm doing that is when I eliminate, which is what I'm doing here, I would like to have the same number in front of the x or the same number in front of the y, and I chose x. So when I distribute this 2 over the x and over the 2y and over the negative 1, I'm going to get a different line. Everything goes up by 2. So I have 2x plus 4y is equal to 2 times negative 1 is negative 2. Okay, and then I'm going to subtract the blue line from the orange line. And if I subtract 2x from 2x, I get nothing. So I could put a 0 there, I guess. I don't have anything. If I subtract 4y from 1y, I get negative 3y, because it's like the 4y became negative and I added it to the 1. And I have 4 take away negative 2. If I'm taking away a negative, it's like adding. So I'm going to divide both sides by negative 3. And when I do that, I get y is equal to negative 2. Well, you know what? That agrees very well with what I got. Y is equal to negative 2. I already said that over there. So this elimination process where I eliminated, the reason I call it elimination is you see what happened to the x. There's no x's left. I eliminated the x's. That left me with one thing to solve for, y. And it's negative 2. I can go back. And let's see, let me use red, and I will show I'm going to use this equation without having changed it at all here. And I'm going to say x plus 2y is equal to negative 1. Go back up to that equation. I could have picked either one, but I picked that one. And so I'm going to say x plus 2 times y, but I now know that y is minus 2. I had a suspicion from the graph, but I know it's minus 2. So I'm going to put that in for y is equal to minus 1. And now I can solve for x. I say x plus, that's going to be a negative 4. So I'm just going to write negative 4 is equal to negative 1. And then I'm going to add 4 to both sides. And it turns out that if I cancel these 4's over here, I get x is equal to 3 on the right side. Negative 1 and positive 4 make positive 3, and that is exactly what my graph said I was going to get. So I feel pretty good about my answer. The answer by graphing and by elimination is the point 3 and for x and minus 2 for y. So that is the answer to the system of these two linear equations. They're linear because they make lines. They make this red line and this purple line. And the solution is where they cross. They cross at 3, negative 2.